What's up, guys? I'm just going to make a quick video about complex fractions and how we can apply those to these polynomial rational expressions we've been working with. So it's kind of just a review on division and maybe putting some addition and subtraction in there with it. So I just want to show you a couple examples here that I think you guys could probably figure out on your own, but I think a little refresher might be nice. So take a look at this first problem right here. So when you look at this problem, it might be a little overwhelming. You see, you kind of have the basically like the rational expression over another rational expression. You might say, well, this looks like too much. A lot of y'all might give up, but remember, all we're really doing here is we're taking this and dividing it by this, right? So whenever we divide, what I suggest you do is you do kind of like a keep, change, flip thing. So you keep the numerator, change the division to multiplication, and flip the denominator up. So it's kind of like you're multiplying by the reciprocal, right? So a quick little adjustment here would make this look like this. So basically, I'm just going to take that, erase it, right, and flip that up. So new problem, all it is just, now we just created like a multiplication problem, right? Okay. Well, all we're going to do at this point is just kind of take a second and factor this out and see what we can cross out, right? So if you look at this top one, what are factors of 6 to add up to -5? Positive 6 to add up to -5. Well, one factor is a positive 6 to add to -5. That's going to be a -3 and a -2, right? And so instead of this, I'm just going to write, okay, x minus 3, x minus 2, kind of like that, right? And here, what are factors of 8 that add up to -6? Well, factors of positive 8 that add up to -6 would be a -4 and a -2, right? So I'm just going to write x minus 4, x minus 2. So basically, I've got this times all this, right? So when you look at all this all at once, you just see what crosses up top and on the bottom. Well, if you look, this x minus 4 and that x minus 4 will go away, right? And then that x minus 2 and that x minus 2 go away. And you're basically just left with x minus 3 over x minus 6. So that complex fraction really didn't turn out to be much. We just, okay, we treat it like a division problem, keep, change, flip, factor, slash it up. Here's what we got, right? X minus 3 over x minus 6. So not too bad, right? So that's just an example of a complex fraction. This is another way to write those division problems, okay? So a way we could apply this to some stuff we've been doing. Check this one out. Let's see if I can scare you guys. It's not that bad, but let's see. So in this problem, what we're going to do is we're going to kind of do some of our addition and subtraction we've been learning with some of those complex fractions. So look at this problem right here. Okay. So we're eventually going to do a keep, change, flip, but what you'd want to do in a situation like this is you would want to make the numerator one fraction and the denominator one fraction. And to do that, we're going to need to look at those common denominators. So let's look at the numerator first, okay? So this one right here has a a squared b, and this one has an ab squared. They're very similar, but they're not quite the same. So in order to get them the same, we just want to give some of the factors that the other one doesn't have. So see how this one has an a squared and this one doesn't? What I could do, check it out, I could come over here and give this one an a, right? See that? And likewise, see how that has a b squared, that doesn't? I could come over here and give this one a b. So in this case, look, in this case up top, my common denominator is going to be a squared, b squared. So when I write it out as one fraction, here's what I got. 2 times b is 2b, right? Plus 3 times a is 3a. And that will all be over a squared, b squared, right? So now I've got the top written as one fraction. Okay. Well, let's look at the bottom. The denominator, if you look at this fraction and this fraction, they don't quite have the common denominator either, but if I just gave this one right here another a and another b, I could get it to this, right? If I gave this one another a and another b, I could get a common denominator. So I'll come over here, I'll give this, check it out. I'll give this an AB up top and an AB on the bottom. And when I do that, here's what it looks like. 4 minus 1 times AB is just going to be AB, right? All over, that's going to be A squared, B squared, right? So now what we've done is we've taken all this jumbled up stuff, right? And we've gotten this 2 fractions, right? Now you can probably guess what we're going to do at this point. We're just going to take a minute and keep change flip it, right? So if I write this, keep the numerator, change this to multiplication, and flip this, here's what we have now. Watch, we got 2b plus 3a over a squared b squared times a squared b squared over 4 minus ab, right? See that? Now, you need to go through and ask yourself, okay, does that factor? No, 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 nothing factors. But if you look, see how we have that a squared and the b squared right there, right? They go away. And our final answer would be 2b plus 3a over 4 minus ab. And that would be our final answer. So you see how we use some of the addition, some of the subtraction, and our knowledge of division, multiplication, complex fractions to solve that problem down to its simplest form. Okay, so hope that helps. Y'all check out that assignment I left for you guys, and just make sure you study addition, subtraction, multiplication, and division with those rational expressions. And if we throw a complex fraction in there, you should know how to deal with that too. So study hard, and I hope that helps you guys. See you later.